Hello, Xinova Network, and welcome to our next webinar. Today, we will be discussing our latest RFI, which is called Packed with Power. And to present this RFI, we have Jason Guo, Innovation Development Manager at Xinova, and this RFI's manager. So go ahead, Jason.
Thank you, Shwani. And hello, everyone from all over the place. My name is Jason Guo. I'll be presenting this webinar. So this webinar's title is Packed with Powers. So it is in the area of lithium-ion battery. This is a very popular topic nowadays with all the EV and portable device. So again, Synovus, we think that problems are a good thing. With that, let me move into today's outline. In the background, I will talk about how battery works very briefly. And why do we move into lithium metal or lithium air battery applications? And I will talk about the challenges that is surrounded in the space of dendrite formation. Then we will visit the current technology in the literature. Then we will go into discussion what's in the scope. What is desire in this inventions and what are out of scope inventions. And we will also talk about in considerations for commercializations, how do we bring this product to the market? There are a few things we have to keep in mind. And I'll close this webinar with Q&A sessions. How does lithium battery works? So as you can see here in the schematics, there's a left and right, which shows you the discharging and charging state. So let me focus on charging, because discharging is just the opposite side of this mechanism. So during the charging cycle, as you can see in the cathode, lithium gives up electrons to the external circuit and then becomes a lithium ion, positively charged. And this positively charged lithium ions moved from cathode through the electrolyte across the separator and then reach to the anode side where it recombine with the electrons and then get lithium ions get deposited into the anode. So this process of lithium ions entering the anodes will cause some changes in the anode structures, primarily a swelling of the graphite structure, where nowadays lithium ion battery in anodes is usually made of graphite. Lithium metal batteries, like I mentioned in the earlier slide, in today's lithium battery, graphite is commonly used for anode, which is the negative electrode. So by replacing that graphite with a lithium metal, what we could achieve is higher energy density. A picture from the literature shows you the energy density or specific energy. It is a matter of looking at the energy per volume or per weight. So here, maybe we can specifically look at a specific energy that is by weight. That shows you in sort of a flesh color, where nowadays state-of-art lithium-ion cells can reach a specific energy that is around 250 watt-hour per kilo, where lithium metal battery is slightly sort of better than what is shown here is the lithium transition metal oxide. So lithium transition oxide is around sort of a 350, 340. It is believed that lithium metal battery can deliver a specific energy of around 440, 450 watt-hour per kilo. The theoretical capacity is much higher. We are talking about around 3,800, but it's a theoretical value. It is most of that's the ceiling. but usually the practical value, we're looking at 450 for the lithium metal battery. And if you can further in the future, you can transition into lithium sulfur or lithium air, which both require the lithium metal as anode. If you move in the future, if you can address some of the concern, the potential of the practical value can go over even 1,000 for the advanced lithium air batteries. But now we are just going to focus on lithium metal battery, which is the first step to enable the lithium air as well. So because of this higher energy density, it allows to have, if we keep the same technical performance for the battery, kilowatt hour, it enables a lighter and smaller battery. Or you can look at the other way around. If we have the same limitations on weight and size, with a higher energy density, it will allow a higher performance, which translates into longer driving range. So dendrite formation, this is the main challenge that we have in this RFI. In a perfect world, you can see the top is the cathode, the bottom is anode, which is made of the lithium metal, and you have a separator and electrolyte in between. In a perfect world, you will use lithium metal that is has a perfect surface, a smooth lithium surface, and on top of it, you have the green layer, which is the solid electrolyte interface. So in the ideal world, when the lithium ions move from cathode to anode or vice versa, you want to have a homogeneous surface, not moving up and down. However, this is the ideal world or perfect scenario. In a real scenario, it's not the case because during this kind of cycling, a rough lithium surface has formed. You can see here is in the B, you start to form these bumps. And then because of that, the nucleation site start to happening at the peak or the valley. So you have those inhomogeneous nucleations. And the next step is that you start to see the formation of dendrite, which is this big peak here. So this is a main challenge here because this dendrite formations, the volume increase is very localized. And therefore, because of the dendrite during the recycling between charging and discharge, you start to form this dead lithium layer, the dead lithium, what I'm showing here in the triangular shapes here. So those cannot be used later on, so your performance started to degrade. But the bigger problem is that if this dendrite formations, the peak hit the cathode, this will be a catastrophe because short circuit dendrite touch each other, it becomes a short circuit. This is where the main safety issue becomes, and we have to avoid that. And during this cycling event, you can see that the volume is going to change for the anode is going to change. We need to be able to control how it change. Also, during the change, we don't want to form this dead mothy layers. And you can see that during the depositions at the edge, this porous depositions is also not ideal. So we have a challenge here. We need to come up with solutions that allow us to control the dendrite formations in a way that you can minimize the mossy growth, that is the dead lithium, and also to prevent the short circuit event. Next is the current technology. This is such a big challenge. We are not asking all the network to tackle every single area. Therefore, we have focused on a few areas. The area that is not of interest, out of scope, that is cathode selections, electrolyte selections, or electrolyte additives. what we are interested in are in the highlighted in the bold text. That is separator selections. And in separator selections, we have some of the example we found on the literature. For example, an approach to enhance the mechanical strength and ion conductivity. Separator augmentations, there's is also our interest, that using organic or inorganic films, coatings, ceramic particles, modularly assemble interlayers. Those are all within scope. The next thing is the anode. There's things that you can change with anode. First, you want to think about the incoming material. How can we make a perfect surface? Therefore, you can do some treatment. You can do some polishing, or you can do electrical, chemical, physical pretreatment, or you can move on. Let's think about not having a perfect surface, but a structure anode that allows you to control the dendrite formations that include the lithophilic matrix, conductive matrix. And we have more details of this technology that we have mentioned in the RFI document. And I encourage you, if you have an interest, have a closer look at it. Make sure that your invention or solutions have differentiations from this existing approach or technology. Next, I would like to move into the invention suggestions. What is required? So, design, fabrications, and compositions of the lithium metal anodes, separators, components of the lithium metal batteries. That's the main focus. Contribute to dramatically improve the battery longevity while maintaining high coulombic efficiency. Also, we welcome any of the approach that can inhibit or eliminate dendrite formations and the risk of catastrophic events such as short circuit. Next is the desire, but not require, that is to have the extremely high maximum theoretical energy. Also to reduce the adverse reactions between anode and electrolyte. And a solution that can address the anode volume expansions or shrinkage during the cycling. It can operate effectively for a variety of liquid electrolyte. We understand that it might not work for all of them, but if it could, it's an ideal case. Invention that is out of scope. The inventions that other than anode and separators that is out of scope. Pure electrolyte modifiers. We are not looking for a new type of electrolyte. You can imagine that if there's a suggestion for electrolyte, we have to do a lot of tests. So we rather focus on the existing electrolyte or commonly used electrolyte. External factor such as cell operation routines. So if you during the cell operation, you have a charge, a discharge. You can have a surge of the currents that during the to dissolve the electrolyte. So those external operating routines are out of scope, and we are not interested in lithium alloy as well. Commercializations. So eventually, the solutions, the goal is to bring the solutions into productions. So what do we, therefore we have the few things in mind. Although we want crazy ideas, but we still have to be realistic. Think about longer term, how do we roll into the productions? So first one is the cost. Think about the additional materials, manufacturing, or specific handling requirements. Those costs should commensurate with the performance improvement. Ease of durability. It should be process should be durable, able to withstand typical operation conditions, temperature swings, and vibrations, and it is expected for multiple years of operations for a vehicle. Ease of adoption. The disclosed solutions that are easily incorporated into the existing manufacturing process and battery cell design are preferred. Component end of life. The ease and potential for the recycling of the battery cells that is disclosed should not be significantly worse than the existing battery cell. The next thing is the safety. The safety of the battery cells incorporating in the disclosed technology should not be significantly worse than existing battery. Lastly, the regulations. All the novel technology or idea should meet any of the relevant US or EU or regulations in Asia. So before I jump into Q&A, I would like to encourage our inventors or innovators, before you submit and jump in to write a full report, please utilize our pre-submission feedback. That will save you a lot of time. If you have questions whether this idea is within the scope or out of scope, send me a pre-submission feedback and I'll let you know. That will save you a significant amount of time, so you don't work on the things that at the end is just a simple out of scope. So the way to do it, you can click on the button that I'm showing highlighted here, and then you usually an IDM or myself as our manager will get back to you within 2 to 3 days. So with that, let's look at the questions. If you have questions, please put in the message board and we'll answer them.
Thank you, Jason. So as he noted, you can submit any of your questions now, and to view the Q&A feature, there's a button on the bottom bar that shows up on your computer, or if you're accessing the webinar on your phone, I believe the button is at the very top of your screen. Okay, so our first question is, will the presentation be available along with the recorded webinar? And yes, absolutely. The webinar is recorded along with it's recorded as a video, and so you can see the slides along with the presentation.
So Shivani, I think also that you're asking whether the presentation itself is available. I think currently on our RFI or opportunity website, we have posted a link for the video. We'll work with our platform team, see if we also can place a link of the presentations for the reference as well.
Next question related to the website, where to submit these ideas. Just visit our website, my.xinova.com, and once you create an account and you visit the RFI page, as you can see on this slide that Jason has on the right, you can see the link to submit a solution on the top right. So feel free to ask any clarifying questions about the RFI. And if you do have more specific questions that you don't want to ask on this webinar, you can always submit it through the pre-submission feedback.
While waiting for the questions, I noticed that this is a special topic that is in the battery space. We are attracting a lot of new innovators. And if you're new to this and you're not familiar with the Synovus, how we work at the Xinova, please just visit our website or reach out to us. We are more than happy to introduce you how we share the upside and share the risk through this project. There are many other opportunities that's available, not just with the lithium battery space. We certainly welcome the new inventors. So please, if you have questions, just reach out to us over the Xinova.com or send us email directly.
So we have a question from David on, since his question is, our invented suggestions will be based on our level of knowledge. So will Xinova staff be able to confirm the submitted hypothesis?
So with our reviewing process, we look at the inventions. If the IDM, the designated IDM, look at idea, if they think there's a great idea or a good hypothesis, what we usually do, we send out for literature review. And then we have a group of, if it makes to the next round, a group of engineers, scientists will have a look at this and review whether it's feasible or not and give you more other feedback. How much detail do you have to get into? I understand that not everyone has the capability of verifying a hypothesis. If the idea is interested, we'll definitely figure out a way to verify it if it's, the idea is attractive.
So we have a follow-up to that question. So just on the same note, once we do confirm that the inventor's hypothesis is feasible, where do we go from that point?
So this is part of a reviewing process, and David, if you have a lot of related questions, I can definitely get on the phone with you and talk to more detail. But short answer to your question here is that if the board likes the idea and then think it's feasible, we will present it to our clients. Our client will decide whether they want to try it and then do some verifications before they make selections. Or if our client doesn't have the specific tool to verify it, but they found the idea is interesting, we might find a third party to verify it. So the idea of this RFI, we are not asking the inventors to come up with a full solution or tool or verifications in the lab. In fact, we are looking for an idea that we will do the verification concept development afterward if we select them.
Okay, next question is, can you say what the specific use cases for the new battery will be? Is it going into consumer electronics product?
I think lithium-ion batteries can be used for portable device, consumer product, or it can also use for the storage on the electric vehicle, and it can be also used for the energy storage on the grid level. The technology like this, of course, our client is mainly focused on the electric vehicle energy battery, but this technology, it should be also applicable to other area, for example, the consumable electronics or any other energy storage applications. It shouldn't be just narrow, but it has opportunity to go elsewhere as well. So I see, David, you have another question. Well, I think Shivani might just answer it already.
Yes, sorry, I went ahead and answered that one. So next question is, learning from the success story and failure of the construction of Panama Canal, how can we prevent optimism, which may blind our feasibility? I may not have understood that question. So Jay, if you could clarify that question, go ahead and submit another one, just to clarify maybe what you're asking here in the context of this RFI.
And also, Jay, if the question is not related to this particular RFI in terms of technical or other related questions, I suggest go on our website, and we will have more specific staff answer you those related questions, more general questions.
Okay, so we'll wait another minute, and we'll focus on questions relating to the RFI. And we're really excited to have a lot of new inventors coming to this webinar and asking great questions about Xinova. So I would highly encourage you to reach out to us, and we can get in touch with you by phone or by email and talk you through a process in more detail.
Yeah, in the same line, we have a lot of short animations videos that describe how it works at Xinova and how do we do this, how do we submit a report. With a follow-up email, we'll send out those links, and I encourage the new inventors who has not participated in the invention with Xinova, have a look at this. You'll find it interesting, and if you have more questions, we are more than welcome to answer those questions.
Okay, so we have a question. It's related to the topic of this RFI. Is this in reference to the 18650 cell format?
Let me get back to you on that. I am not an expert in this field, but I will answer your questions off the line. I will send you an email to follow up on that.
Okay, so since we are at the end of the half hour, we'll go ahead and wrap up here. If you have more questions, again, you can reach out through the pre-submission feedback, get feedback on your ideas, or just ask questions about the RFI. And again, for those of you who are new to Xinova, you can reach out to us through the same button, so the very same pink button on the bottom right that is on the slide. You can click on that button at any point in the website, and that will reach Jason, myself, or another IDM, and you can ask any question about Xinova, the process, and from there we'll reach out to you and continue discussing further. And there was just one final question or comment. So questions related to the RFI, we'll be happy to share the answer to those questions to the group. So someone mentioned specifically about the 18650 cell. So yes, we can definitely be sure to share the answers with the group. Okay. Thank you, everyone, for your time.
Thank you. Have a good one.